So let's start. Hi, my name is Daniel Al-Gaaf. I'm working for Deutsche Telekom, and I'm presenting to you today about Ceph-based enterprise storage we brought into the field. You probably remember the talks I gave before. The last was in Barcelona on a Cephalocon. That's a while back. I missed some Cephalocons due to personal reasons. So this is if you have seen this presentation, some parts you already know. I give a short introduction into the system and what we built, and then we go to how we got it into the field. So this all is about the Telekom email platform for our customers. So every customer that has an account with Deutsche Telekom or had an account actually gets an email account also for free and can store and receive emails. But these accounts internally also contain the voice recording. Actually, if somebody on his mobile phone, for example, gets a voice call and it goes to the answering machine, that is stored also in the system. We use for that an open source system, it's Dovecot. That's a pretty big market share. We use it since, I don't know, 20 years or so or longer. And actually, it's running on a NAS system, on a classical NAS with a sharded NFS system. And from the dimensions, currently we have there in around 50 million accounts. That was at least the number from 2022, I think. That makes around about 14.5 billion emails, and it's around 2.2 petabyte storage. And from the NAS side, it's the setting is that we have around 42% of raw storage we can use for storing emails. So what is our motivation to move away from that or explore other technologies? So from the technical standpoint, we need something that is faster and self-healing, because these enterprise NAS systems all usually use some RAID controller, and if the devices are failing, the ops guys are sitting there and sweating that nothing more is failing, and it takes a lot of time. So what we also need or wanted to have is a global namespace. Currently it's sharded. That means also that you assign mail queues to a specific instance of the NAS, and we want to get rid of that. We would like to reduce the I/O overhead. And from the business point of view, we want to get away from being locked in with a specific vendor. We would like to use commodity hardware directly, and we also would like to use, or the plan was to use open source where it's feasible. And at the end, everything comes down to reducing the total cost of ownership, because you don't make money with that. So that's the email platform is a giveaway for free, and you make no money with it, but you have trouble if something goes wrong. So our approach was, there was no open source solution on the market. Dovecot didn't provide anything to get, in this case, Dovecot on Ceph. Though there was a closed source solution from the Dovecot guys, but our point of view is that we don't want to pay licenses because of cost. So we decided to develop and sponsor our own solution. We open sourced it and started with a project around 2016-17, and had some partners on board. One was Talents. These are guys that maintain our Dovecot system since years and doing development for us. We had SUSE on board for Ceph and the OS, because in this area we always had run before our mail queues on SUSE. And in the beginning we also worked with Vito about the concept. That is what we implemented basically. So what we are doing is we wrote a plugin for Dovecot to manage mails on Ceph, and we put the actual email objects, one object at a time, as a Rados object down into our cluster. No Cephfs included, nothing else. It's directly Rados. And we are storing some of the attributes that are not changeable for an email, like date of receipt, dates and UIDs, actually in the OMAP key value store. And the other part is that we have, where we didn't want to change too much, is indexing and cache filing, and that is going actually to Ceph in our case. Because they have basically already plugins to do that. Not Ceph specific, but file system specific. So we open sourced it, it is under LGPL. Written it in C++, and since 2023 it's version 1, so it should be usable. We recommend try it out and give us feedback, and you can get it from GitHub. So let's see what we did. So the hardware, I have to say this hardware is now it's 6 years old. So it was standard HPE DL380. And we had two types of nodes. One was a performance node that basically runs MDSs and OSDs for the Ceph part, running all on flash. And the other one have been capacity nodes with 10 4 terabyte drives, HDDs, to store the emails actually, because the email is only written once and then it's read. So, and we have a lot of mails that never be read again, but we need to store them, so we decided to do it on HDD. So what's the cluster setup? It's a classic setup with 3 file compartments actually, and we had 6 nodes per file compartment for the emails and 3 nodes for the Ceph part. So what will have been the requirements for production? The first one is customer data can't be lost. That was the most important one, because there's a lot of trouble, even if even one email gets lost with the wrong person. So it's at least 3 replica or comparable, and it must be operatable at any time. So we had to cover some failure scenarios, like a file compartment fails, a single server fails, an OSD fails, and so on. And as I said before, it can't cause the data loss. So from the settings here, we run erasure coding on the router's part. There is an overhead with very small objects, because emails are usually small. The peak is around 64 kilobytes in our systems, an email, but we also have cases where we have 500 megabyte emails. Nobody knows how they got in there, but they are in there, and you also have to handle this. And for Ceph, we ran actually 6-time replication. The reason basically was how we use these cache files and index files. They are really small changes and appendants, and if with erasure coding and all the partial rewrite stuff at the time, it wasn't feasible for us. So we had made a proof of concept, and we had some limitations. So we ran with SUSE and had to stay with the product because it was already there, and we don't want to have not reproducible results. So we hang on a Nautilus in this case. There haven't been any hardware changes, no placement changes in between. We didn't make any major changes to deployment or automation. So in phase 1, this was basically run load tests and run all the failure scenarios that we had in the ops handbook that need to be covered. So there have been full synthetic, but customer-like patterns, but that is with an email system not that simple, because you have also stuff like generating pictures from the email or generating specific information from an email that you can't simulate, because if the customer is sending a big picture or a small picture, and you have to generate a thumbnail that has an influence on the system. We covered all hardware failures, took a look on the load impact in this time and how it's recovered, and what operational procedures we would need. And at the end, the topic was to improve and fine-tune the setup and verify and optimize the hardware. In phase 2, we did a limited real-world test. So that means we took customers, or plan to take customers, and move them from our current system into the mail platform. So there is no specific code to do that is Ceph related, because Dovecot itself is able to move accounts between different storage setups. So it was step by step and then increasing. We had to identify issues in the migration process and learn at the end about the real load. We let it run 6 months and see what happens with all the customers doing something. At the end, the plan was to create a decision for the management, right? So how to go forward. In phase 1, as I said, it was the physical setup was, as before described, radars on HDD and Ceph on the SSDs. And we had 3 mons and 3 managers and 3 MDS nodes. In the beginning, we also only had 1 MDS per node, right? What came out of that, you will see later. Running, we had 36 incoming mail queues generated on different servers to push the test into the system to test what will happen. And on those machines, we increased the number of accounts that are handled and receiving mails and pushing it into Ceph. And the focus was on performance. If we lose data in all these cases, and mainly on processes, and the impact on the customers. And the point is that not every issue you see in Ceph or in Dovecot will be seen by the customer because it's not synchronous, right? And you have a lot of cache files and mail queues in between. So even if the Ceph system would have a low latency at some times or had trouble, that doesn't mean that we lose data or that the customer would see that. Because usually customer don't know when the email arrives, right? So if it's taking a second or it takes 10 seconds, it doesn't really matter. So, the test scenarios we covered there have been typical hardware failures, like an MON or an MDS node or a single instance is failing, that a single OSD is failing on the Ceph side and others is failing on the Radar's mail part. And also to test what happens if a fire compartment completely fails, and if then additional OSDs fail on the other remaining side. We also had some technical tests with the network-related failures. So we introduced failures like the front end failed, the back end failed on an OSD, on multiple OSDs, and also that the most ports of the machine, we had 4 ports for each machine 10G, that 3 out of 4 is failing. And we also tested these usual admin scenarios or ops scenarios, like what happens if you remove a node, an OSD node, or if you add one, if you restart the full cluster or update the network fabric that is there, or update Ceph under load. And what we also tested is what happens if ops missing the point where the cluster is running full. Besides that, there have been some not really Ceph-related issues, like what happens if the systems run different times and the sync is running out, or even if the automation is failing and doing something to restore a node from the admin nodes that we run with SUSE, but that is not really related to Ceph. So I took some test cases we ran and want to show them. So what we here did is we tested in this case that a fire compartment completely fails. This diagram is from one of the clients running the actual load. So at this point there, we killed the fire compartment, took the power off, and immediately set no out, because that is what the procedure we would recommend for our admins to do. Then at this time here, this little peek down, you see we took out an OSD on the remaining part, on the Ceph part, and one on the router's mail part. So there was a little impact here, but what we finally did, at this point here in time, we brought back the single OSDs and it did start some recovery. But this, from here on, we brought back the fire compartment, so you really see a small impact or a time of impact actually on the client side, that it's going from time to time down to 0 I/O. The blue line is actually the write performance, and the red line is the read performance in this case. And it took around 2.5 hours to really come back to a stable state where it was completely recovered and everything. And we also tested the case where the cluster ran full. That was a little bit difficult to set up because of time. So filling up the whole cluster with all these loads, it would take a lot of time. So we decided to take 9 nodes out of the cluster, 3 on each side. Actually, we have seen that the recovery would take really long. So we decided, okay, let's clean up the cluster and fill it again with a smaller cluster, right? But the problem here was that it would take barely a day to simply delete the pool with all these objects we already had in there. So we decided instead to simply redeploy the nodes and zero out the drives and bring the cluster up again. And then we filled it up to 90%. And started the test to see what happens if it's getting to 100%. And actually, we checked the cluster behavior and to see what's also happening if we then add new nodes, the standby nodes. And actually, the result was that takes a pretty deep effect on the on the clients. So they go down to nothing, right? And it takes painfully long to recover from the state, and even if you add these new OSDs. But we didn't lose any data, actually, and the admins now know that it's a scenario they need to prevent at any cost. So actually, if you take a look on that, there the pool was full completely, and somewhere in here we started adding single nodes, and it doesn't really change anything. Only after we added more than 3 nodes on each side with 30 OSDs, it started slowly to come back to a state where it really was active again. And as you see, the I/O basically was 0. From time to time, you had a peak, but basically it was going out to 0. And it took, at the end, 7 hours after we added the last 3 nodes to come to a state where we could use it. So what are the results of this POC or the real-life test? So we tested here 22 major test scenarios. At the end, we had none failure. That means we didn't have anything we wouldn't expect, and that couldn't be handled. So we had no data loss. That was great. And compared to the NFS part, we didn't see, compared to that, no unexpected behavior, and it was a comparable performance if we compare it with a NAS that also runs on HDDs. In phase 2, the object was to test with real customers, right? So because you really can't simulate a real customer behavior, so we selected randomly out of our existing pool customers to be moved. And we tried to keep the typical distribution we have on large mailboxes, small mailboxes, users with a lot of large mails and so on. And we tried to keep the size of emails the same as we have currently in the cluster, but we then, in the process, hit some cases where we had mails of 250 megabyte or larger, and then we excluded those because we ran into the issue that the maximum Rados object size got over, and we moved that out and ignored this for now because new users can't add that large emails to our system. We tested with that the migration process from an existing system to Ceph to identify also the cluster limits that we have, and we then ran the cluster after the initial import 6 months with the customers on it, receiving emails, sending emails, and so on. And we learned from that the cluster behavior. So After that, after the 6 months, we moved that back to the NFS system, these customers, also to see if the migration process in the other direction really works. What are the results? The most of the issues and bugs we have seen are caused by the effect of, from the side of Dovecot or the implementation of Dovecot and the plugins we are running, because the system is running that long. We had emails with attributes that nobody knew where they came from and in which Dovecot version they have been introduced and not correctly managed. So we had to fix a lot of Dovecot stuff, not so much on the Ceph part. In total, we moved 1.1 million accounts over to Ceph, which means it have been 440 million emails in total, something around that, and then growing after that a little bit. That means also we had 4 billion erasure coding chunks on the system. And from the mail part, it has been something around 400 terabyte that has been moved in the system. And on the Ceph FS part, with all these cache files and indexes, it has been 27 terabyte. It was a successful test. We had no issues before customers. We had no data loss. And we have been really happy with that. So as here's the Grafana part of that. As you can see, it was somewhere in between the migration. It was 4 million emails in the system, actually, and the read performance was comparable good. It was 400 megabyte per second in the system. At that point, the write throughput wasn't that high because the receiving emails is probably not that high. It was high between or during the import phase. So what did we find and learn? We had some cases. The first one was obviously MDS load distribution. Because the tree is really big. Every customer has in the namespace a separate namespace, and all the emails are one object, so it's a really big. On the other side, it's all these index files representing something else, something comparable. So you have multiple indexes, multiple cache files per user. It was a lot of files there. So the initial performance was low during the import. There have been some bottlenecks, and it's mainly because parts at that time of the MDS are single-threaded. So and because of how we use it. And also the cache and memory default settings haven't been fitting our use case. So basically what the solution was, we ran multiple MDS per node. So in total it's 16. I know that's not the best way because 3 nodes through 16 doesn't really work. And we had also 8 standby MDS. We didn't use the dynamic load balancing on that because it wasn't reliable, and you don't want to have moving around stuff all the time. So we decided to pin the subtrees to some user parts and pin them to a specific MDS in this case. The other stuff we hit is in the night we run some Dovecot specific workloads that are not really customer related. That means we run, for example, expunge job. So that means emails that in the trash folder that are older than 30 days get probably deleted and stuff like that. Or mailboxes that are not needed anymore get deleted. So what we ran there was also into a bottleneck that was caused basically because of the file structure and the MDS pinning. The solution in this case was we couldn't solve it with the general approach. So we moved these jobs and the files that the jobs create to a different Ceph FS instance and to specific MDSs. And then we didn't need it there, the substitute pinning, because it was only a low number of jobs that are running there. One of other topics we failed and hit in the tests have been MDS failover. We have seen that it's from time to time a little bit slow if an active is failing, especially because we didn't run them as hot standby, but at cold standby. So we had this replay, and it was, for us, a little bit slow. And especially because the replay, right? If it's staying cold, then it needs to be replayed. So we decided to add actually standby replay servers and ran 16 active, 16 hot standby and 16 cold standby MDSs. And the fact is that the nodes not really have been from the CPU load full, right? So it was easily possible to run this on 3 nodes. But after some time, it caused some new issues we have seen. We are not completely sure why it's happening, but sometimes it happened in our case that locks that have been set by Dovecot, and if the MDS is failing over, some of the locks stayed at the failed on the failed MDS and haven't been really cleaned up. And after coming back, we had some locks that have been there and shouldn't be there. So we actually decided to accept the fact that the cold standby takes a little bit longer. So we removed the actually hot standby MDS again. So one topic we also had is that to recover broken mailboxes indexes. So if you lose an index in Dovecot, that means that the user box is away and you can't find the emails anymore. And to solve that, you have to search through the whole namespace. In this case, it means 440 million emails to check the extended attributes to find the emails that had belonged to a user. And that was painfully slow. You probably know that from LSing in Radar's pool. That is comparable from the workload what we did. And listing all objects, it took very long. So basically, as the LS code was at this time for Radar's LS, it wasn't parallelized. So it was sequential running through all objects, and it takes painfully long time. So the solution for us was, in the beginning we thought we parallelized that, but it wasn't really the best solution. So we actually changed the internal structure of our plugin to keep an additional index to keep these UIDs together to prevent that, and then use this input to find the emails again and mark them in the correct mailbox. The performance during the initial import, we reached a point where it was not really, it got slower with more accounts in the system. So we ran a performance analysis, and the main issue was that we had a lot of PGs, but they got too big and there are too much objects in there, basically, and we didn't use in Nautilus auto-scaling. And we wouldn't use it yet now because we really want to move something around. And also the num trays have been too low. So basically we increased the number of PGs, split that, and after doing that, even the scrubbing was much faster than before. And we increased the number of strays to 2 million. I think the default around that was 1 million. And that basically solved most of the performance impact. So if you come to the findings at the end, there's also this topic of cost. There are 2 topics we can put together. One is power consumption and space and density. Both are connected for us. If you take a look at power consumption per account or per terabyte compared to what the other NFS is doing, it's much too high currently with this hardware. The point here is that the hardware is really old, right? The energy efficiency per terabyte increased in between these 7 years massively. So the solution is here to have a new hardware concept to increase the density. Now you can have 30 times more space actually in one node or in a 2U node than before. The CPUs are also more efficient, right? And the other point is that if we do that, we also probably need to change the network, and we have to take a look on the cooling if we increase the density. But it opens probably the way to use a more efficient erasure coding. So if you take a look on it, I took a look on from our hardware vendor, what we had before, that was the power consumption per terabyte on the left side. And actually, if you take a look on today, you can have only a fraction of that. So the most efficient would be to use 24 terabyte HDDs. They have the lowest, and for SATA, it's a little bit less than SAS. And NVMe is not a point for us because we don't need this performance, and with NVMe, it would take a lot of more power. So probably SSD is the right solution. And the other side of cost is, that's a little bit funny, network ports and support. That is mainly driven by internal data center cost. It's a strange policy, but at the end, if you compare the number of ports that Ceph has and the number of ports the NFS had, Ceph has a 60.5 higher number of ports in this case. You could reduce it through having only one 100 gigabit connection, but it doesn't really solve it because the issue here is that the NFS is coming as a black box and only the interconnect out of the black box is counted. And with Ceph, you have this own network structure and a lot of ports. That means from the project point of view, it's a difference between annually network port cost from 4 digits to 6 digits. That is a big impact on the calculation. The other topic is that, and as you know, SUSE Enterprise Storage has been cancelled and discontinued. So we thought about how could we kill two birds with one stone, and it's actually to change it to a storage appliance. So that only the outgoing ports of the appliance of the rack is counting, and we also can, in this case, then get support. Here, what are the conclusions? You can run Ceph even on large setups like ours to run emails on that compared to NFS. But it needs a lot of, on our side, a lot of optimization in the cluster concept. That is one point, as I said before, is increasing density. That would mean to move the RADOS email part actually to SSD to reduce the power consumption and increase the density. You also would recommend to still use HDDs, and the point here is we have around, I'm not sure the actual numbers, but usually there are a third of the accounts are only active, the rest is inactive, not really often receiving an email. So you could easily use these accounts and move them to HDD, right? Big HDDs, put them on, the performance doesn't count, and if they get active again, you could move it back, and the tiering actually doesn't need to be done in Ceph because the Dovecot has the infrastructure to move accounts around. So you could run nightly or weekly jobs to identify boxes that are, or accounts that are not active and move them around. One is to increase the network simply to reduce ports and to get a better latency. And what we need to do is working on the erasure code settings, especially for the small objects that are a large part of our emails in there. And the topic that is currently missing or we didn't test, and that is snapshotting, because the NAS system is able to snapshot the whole cluster or parts of the cluster, and that's something we would like to have, but currently we don't want to snapshot the whole RADOS pool, right? So it's in summary, we decided to get on, that is something we could get through a partner that would offer us a storage appliance to replace on one side the SUSE Enterprise Storage with an up-to-date Ceph version and get us to the support for Ceph, and also working with us on optimizing the plugin. And that is basically Clyso. We decided to use for that and work together with them. So I would say the project was a success, and we're looking forward to create a internal business case that then gets a decision to really move that current system to Ceph, actually. So I invite you to, if you're running email systems, get the code, run it, test it. If you have done, I would be happy if you give us feedback on it. So thank you. Any questions?
Very quick question. What's the backup story?
What?
Do you have a backup story?
No, that is what we want to have. To be honest, we don't do backup now, so there's no backup. So that is why we all want to have snapshots, actually. Yeah.
So yeah, you mentioned that you have relatively small objects because it's emails and stuff.
Yeah.
On top of this, you do erasure coding.
Yeah.
So I guess you end up with really a lot
Yeah.
of very, very small objects.
Yeah.
You didn't really speak about issues with this, but do you have like during deep scrubs or I don't know, fragmentation on the disk or stuff like that it starts to be a problem?
We know there is an overhead to that. We didn't really investigate it because we didn't have the time. But yeah,
you're talking about the size overhead in this case.
Yeah, because if you cut it in 4 parts, right, and that is all a 4K email object, then you know there's an overhead that's.
And you don't use compression on the pool or anything like this?
Actually, on the email pool, there's a compression also running. Okay. So that is why there's a small difference between what Dovecode is currently seeing and what is actually on the drive. So there's a compression running on it, yeah. But the peak is actually around 64K, that most of the objects are that and larger. So then it only hits a part of our emails that is smaller and causing an overhead.
64K is before you split it?
Yeah, before I split it, yeah. So and if I split it in 4, it's still fitting into the 4K, right? So.
Thank you.
Have you considered using NVMEs as a DB or a wall device?
Yes, in the future, but at that time it wasn't something we had, right? So yeah. On the OSD nodes, we still currently have SSDs to cover this part, but it probably makes sense to switch to NVMe there. Yeah, because one drive is sharing currently, I think, 5 OSDs. So yeah, it would benefit from it.
So for a SATA or a SAS SSD, 5 OSDs in the background is kind of a big workload, but in comparison to what NVMEs nowadays can do, especially if you're looking at Gen 4 or Gen 5 NVMEs, they're just laughing about it.
Yeah, I know. Yeah. So you could use one, right? So yeah, currently 5 HDD OSDs are covered by 1 SSD in the current setting. So yeah. Okay. If you have any questions, come to me. Oh, there's one.
Are you running on Dovecode version 2?
Yeah, 2.3, I think.
Will your solution be supported for Dovecode version 3?
Yes.
Great.
As far as I know, yes. I'm not completely sure. But not after that, there was some change we didn't yet introduce into the system. So there, you have to take a look on the GitHub page what the current supported version is. There's we also don't support much older currently because there have been some changes. So it's 2.2 and 2.3, I think, that is supported currently. Okay, then thank you.